we're going to look at multiplication and division of whole numbers. We start with a mental computation or a problem to do without writing on a pencil and paper. 18 times 5. Go ahead and calculate that. Pause it so you don't look at the solution. Okay, now how can we, what are some different ways people would solve that? I wrote a couple of down here. Some might do 18 times 5 is the same as 5 times 10 plus 5 times 8. So you get your 90. Some may say 20 times 5 is 100 minus 10. And that comes from 20 minus 2 is equal to 18, and then using distributive property. So those are two different ways to calculate that. You probably came up with a different way potentially. And really want you thinking about, again, the thinking strategies as we talked about in the previous section. How about this discussion question here, or something to think about at least? What would a word problem be for 3 times 4 if you thought about that? Think about that a little bit again, but again, this is for a discussion in the class or with peers. But think about the type of question you would ask for that. Now, let's go ahead and look at what multiplication is. And so one approach to multiplication is what we call the repeated addition approach. That multiplication is just that, right? And so we have this situation here where you're looking at these 5 groups of 3. You have a set model that represents that and a measurement model. And the multiplication problem with that is 5 times 3. 5 groups of 3 equals 15. So multiplication really is, in one way, repeated addition. And that's our first definition of multiplication, right? A times B is just B. A times A add-ins, right? You're going to add B together with itself that many times. We also know if A equals 1, then A times B is equal to B. 0 times B equals 0 for all B. And so what we're looking at is multiplication, and the way we can write it usually is 2 variables next to each other, AB, and we say A times B. The answer to that is called the product, right? And then the product of A and B. A and B are what we call factors. That's a key term to know as we move forward. And again, like we said, anything times 0 is 0. And so this is our first kind of look at multiplication as repeated addition. And that's kind of a traditional way or classic way people view multiplication. Another way to view multiplication is through what we call the rectangular array approach, that the number of elements in a rectangular array, right? If you look 4 and 5, how many are here? You get 20, and that is what your product would be, right? AB is the number of elements in a rectangular array having A rows and B columns. And so there's your 4 times 5 would be, how you count how many you have. You have 20. You could also kind of draw it this way. But really, it's multiplication can be visualized, right? There's a visual to it, and that becomes an important aspect for young children learning multiplication, in addition to the repeated addition, that you have a rectangular array approach to look at that. And so multiplication can be represented that way. And then before we leave multiplication, remember there are some properties, just like we had it with addition and subtraction. A closure property, the product of 2 whole numbers is a whole number, so it's closed for whole numbers multiplication. But what about for odd numbers? Are odd numbers closed under multiplication? Meaning, if you multiply 2 odd numbers, do you get an odd number? And again, just from the pattern, from some inductive reasoning, I would say that odd numbers are closed. And we could prove that with some algebra, but that's not our purpose right now. I would say it's closed. An odd number times an odd number is an odd number. So odd numbers are closed. How about negative numbers? Negative numbers are not closed. You can see, because a negative times a negative equals a positive, so it falls out of the set. We also have the commutative property that we learned for addition. A times B equals B times A. It works for multiplication. How would you explain this to a child? One A specific way is to look at the rectangular array. You can look at a set model, right, and they can actually count those out and learn that. But you can see from a visual, 5 times 3 is the same as 3 times 5. You can actually see those. And then the last properties that you want to be aware of for multiplication are the associative property, again, that you can rearrange the multiplication problem. A times B times C can be A times B first times C. And then we end up using those for thinking strategies, right? So for example, 15 times 4 can be 3 times 5 times 4, right? To figure that out using associative property. This is a nice visual of 2 times 3 times 4 in terms of looking at how it can be broken up different ways, but they have the same number of blocks, right? 2, 3 times 4, 3 times 4, 2 times here, and then here you have 2 times 3, 4 times. So it's important to remember the associative property for multiplication of whole numbers. We have an identity, which is anything times 1 is itself. That's called the multiplicative identity, or the identity for multiplication. And then we have a famous rule or property, the distributive property, that works, and we're going to use this to do some calculations. Also, 4 times 8, I know we know the answer is 32, but that can be seen as 4 times 6 plus 4 times 8 if you break that up, and that comes from the distributive property. And again, this nice visual, you can see how 3 times 2 plus 4 is 3 times 2 plus 3 times 4. You can see visually the breakup of that. And then the example here, you're going to take a look of distributive property. Most students are pretty familiar with that, and you can see here the solution right here for those problems. Right, so there's your solution for those problems there. Take a look at that and pause as you need to see how distributive property was used there. And I think that would be it for now. You can look at these properties here real fast. Which properties are addition and multiplication share? And they share them because they're related to each other, right? Anything times 0 is 0, and then distributive property works for subtraction.